Welcome back, guys. This question involves a bit of geometry, and whenever a question has geometry, diagram is the first requirement to do. Here there is a cube, and whose vertices can have values as either 0 or 1, which means the cube has a dimension of 1 unit on each side. The six faces have two diagonals each. The 12 diagonal lines belong to the set F. And set S carries the four body diagonals of the cube, and you need to find the maximum value of the shortest distance between any two such diagonals. I hope you will be able to refer to this question by going back on the video. For now, let's start solving this question. Now see, the diagram is actually of a cube, and in the simplest sense, if I draw a cube, then the vertices can be easily located, and that is the benefit of taking a diagrammatic picture of a cube. Say for example, we take a cube like this. This is one side of it, and let's say it goes below, and then you take a side like this and like this. That's all. And this is the cube. Now let's say this is your origin 0, 0, 0. This is your direction of x. This will be direction of y, and let's say this is the direction of z. 1 unit on each side is to be taken. Now let us consider the body diagonal here. That means from origin to the point of A. Let's say the body diagonal runs approx like this. I will call this body diagonal as let's say line of L1. Let's say this is your line of L1, or L1 is a vector which belongs to the OA vector. And since this is 1 unit each, this is the extreme other vertex, and this coordinates is 1, 1, 1. This L1 therefore is definable as I cap plus j cap plus k cap, or alternately the direction ratios are 1, 1 and 1 as a vector. Now we need to take any one of the faces. Out of 6 faces, 4 walls, the top and the bottom constitute the 6 faces. Let's take any one diagonal of the side, but taking caution that it does not pass through origin, because otherwise the shortest distance will fall to a minimum of 0. Now that means we can consider a position like this. This can be a possible PQ. This can be considered as the line of L2. Now where is P and where is Q? So this is on y-axis. The coordinates can be x value 0, y value 1, z value 0. And this is on z-axis. So your x value is 0, your y value is 0, and z value is 1. Very simple. So x, y values being 0, z equal to 1. Oh yes. So therefore your L2 vector can be defined as a PQ vector, and which can be taken as you can say 0 minus 0 I cap goes plus j cap and minus k cap, and that is equivalent to, you can say, 0, 1, minus 1 as a vector. So I will say that this is a 0, 1, minus 1, 0, 1, minus 1 as a vector. Now I have both the lines, and let's say we consider the line of L1 passing through a particular point of A, and line of L2 passing through a particular point of, let's say, P. So therefore I will define a vector of AP as well, and vector of AP will be 1, 0 and 1. This being a vector, we can also define this as I cap plus k cap as a vector. Now this is a point-to-point vector. The shortest distance that can exist between these two lines can be approximately, let's say, if it is like this, such that this is a 90 degree and this is a 90 degree. This is the D that we are talking about. So therefore the shortest distance can be simply defined as ratio of an STP AP the vector of AP, that is point to point distance between line 1 and points falling on line 1 and line 2 have a vector, then L1 vector and L2 vector, and divided by the magnitude of L1 vector cross L2 vector. Now let's calculate these separately. So your L1 vector cross L2 vector can be written as equal to I cap, J cap, K cap. L1 direction ratio 1, 1 and 1, L2 direction ratio 0, 1 and minus 1. So therefore, L1 vector cross L2 vector is equal to I cap into minus 1, minus 1. It's a minus 2 minus J cap into minus 1, 0. So it's a minus 1 plus K cap into 1 minus 0 is a 1. So therefore, magnitude of the L1 vector cross L2 vector shall be root over of 4 plus 1 plus 1, it's going to be root 6. So the denominator is going to be root 6. Now if I go for the STP calculation, that is a vector of AP, L1 vector and L2 vector calculation, if this STP is to be calculated, it's a determinant. Now AP vector 101, L1 vector 1, 1 and 1, L2 vector 0, 1, minus 1. We will have to calculate this. Let's begin. L2 vector is 0, 1, minus 1. Oh yes. Now 1 into minus 1, minus 1. It's a minus 2. 0 goes plus 1. Now 1 into 1 minus 0. So this is a 1. 1 minus 0. And therefore this is simply minus 2 plus 1, that is a minus 1. So therefore your D max calculation, your D max calculation can be equal to magnitude of the STP here is equal to 1 unit and divided by the root over of 6. So therefore, if this is the calculation, then your D max, which is the required answer of this question, is equal to 1 by root 6. This is a simple question from three-dimensional geometry. It involves vectorial calculations, determinant consideration, and 3D geometrical understanding. Thanks for your patience and see you in the next question. Stay subscribed and stay revised.